All right, guys, last part of these notes. This part is actually going to feel very familiar because we've done it like 4 times, but you're using ln. So what we're actually going to do first is find the inverse, just because it'll be easier for us. And then we can use the idea that our inverse derivative is the same thing as 1 over the derivative of our inverse. So what we're going to do first is actually find the inverse. Okay, and what that means is we're going to just swap the x and y's. Okay, so anytime you see a y, turn it into an x and vice versa. Okay, so that way we don't actually even have to use the rules of natural log, which is kind of nice. So instead, we are going to, well, for the y value, we're going to find the derivative of that now. So we're literally finding the derivative of the inverse. Like, that's literally what we're doing right now. So this is dy dx, right, equals 4x cubed plus 1 over x cubed minus 7 times the derivative of that, which is really 3x squared, and then plus 0. So you don't even need to write that because the derivative of 7 is 0. Okay. Now you can plug in your coordinate that we gave you. So this is your x and your y value. Just a reminder that that was for your original, so it becomes 2, 23 for the inverse. So I'm actually going to plug that in for x and y. So I end up with, well, really, I don't have any y's. So my derivative ends up being 4 times 2 cubed. There were no y's for me to plug into, but if there were, I would also plug that in here. That's a 3 times 2 squared, okay? And that comes out to 44. So if I plug that back in to my formula, that is literally your derivative of your inverse function given that x and y value. So my inverse derivative at 2 is really 1 over 44, because remember, it's just your reciprocal. All right, trying some more of these. We're gonna jump around a little bit. I don't want to make you do all of them, so let's actually do, let's see. I'm gonna have you do this one with me, and then I'll have you try the bottom two. So don't even worry about doing this one. Just, you know, if you were to try that, it says use the derivative test to determine if the function is monotonic and therefore has the inverse. This is like review questions, so I'm just going to remind you of what this looks like. Notice there's no restriction on your domain. There's no like interval given to you, so this is why it's a little bit different. The bottom two are actually going to have restrictions just because of the way the functions work themselves. So I'll talk about the restrictions for this first one, and then I want you to think about the restriction for the second one. So for our thinking of whether this is monotonic or not, we have to find the derivative. Remember, you're trying to figure out whether it's always increasing or always decreasing. So my derivative is negative sine of 3x over 2 times the derivative of the inside. Remember, we have to use chain here. Okay, set that equal to 0. So 0, I'm just going to clean this up a little bit, equals negative 3 halves sine of 3x over 2. Divide both sides, you get sine of x, or sine of 3x over 2 equals 0. If you don't remember how to solve something like this, you're literally looking for where sine equals 0, and then you can set the parentheses equal to that. So what I would do is say 3x over 2 equals wherever sine equals 0. And sine equals 0 at 0, pi, 2 pi, and so on. So like you keep adding. Right, so let's actually do 2 pi as well. What you'll notice is that you don't actually need that many points with these because you'll see pretty quickly like what's going on with your values, especially for something like this because it has a lot of answers that could work. Technically, they're infinite. But if I keep going, I would solve by multiplying both sides by 2. So if you multiply all of these answers by 2, and then divide by 3, that clears that left-hand side. So I get x equals 0, right? Because 0 times 2 over 3 is just still 0. This becomes 2 pi over 3. And then this becomes 4 pi over 3. So we'll do a few. You don't need to do all of them. But what you'll notice is that our derivative, when we plug in around those values, you have to plug into your derivative function, which you can just use your graphing calculator for. But between 0 and 2 pi over 3, you can plug in like pi over 3 if you want. Something that makes sense. You could technically do like pi over 2 if you want. And then like in between 2 pi over 3 and 4 pi over 3 is pi. Things that are nice to work with, you know. And then to the left of 0 could be like negative pi over 2 or something. So what you'll notice is that you get a positive, negative, positive, negative. So this is not monotonic because it goes from increasing to decreasing and so on. So there's no inverse. Again, if you wanted to see how this one works, it's monotonic because it's always increasing. The next two, again, you just want to restrict the domain. Because the domain is a little bit different, for natural log, just a reminder that your natural log function, you can't take the log of anything less than 0. So that's why x plus 2 has to be greater than 0, okay? Because if I take the natural log of 0, that doesn't work either. So anything greater than 0 is going to work. And then I solve, so x has to be greater than negative 2. And then now you can solve it the way that we just did on top. So I'll do both of these for you, but I want you to try them first, so pause the video and I'll have it up for you. All right, guys, check the answers for both of these. Just a reminder that your domain for the second question is x is greater than or equal to 2 because you can't square root negatives. The other reminder is that when you're plugging into your number line, look at your domain first because you don't have to go to the left and to the right of these points for both of them because of the restriction. So both are monotonic and both have inverses. All right, we're moving on. So again, just verifying that these are inverses of each other. These are both just practice problems. So I'm going to have you try both problems on this page, and then I'll have the work done for all of it afterwards, so you'll see what the answer is going to be. And then the last page is a little bit different. So try these two. Pause the video and unpause, and I'll have it done for you. But to verify that two things are inverses of each other, just a reminder you have to do composition of functions. So just keep that in mind. And then the second question is very similar to one we did, I think on day 1. But you can go back and check in the rest of your notes to try that out. All right, guys, check your answers, please. Remember that the top part here, you just have to do f of g of x and g of f of x. As long as you get x for both, then they are inverses of each other. So hopefully that wasn't too bad. The bottom one, if you had trouble with the domain and range, just a reminder that you can't get 0 on the denominator here. So they're saying it has to be greater than or equal to 0. So you really can't get you have to go from 0 all the way into infinity. So because it's inclusive of 0 there, you can plug it in. But if you say that this has to be greater than or equal to 0, the denominator, then you can get the other values for your domain and your range. Technically, you can keep going larger and larger for your domain. But if you try to plug in 0 for your range, you get 4.5. So that's the max y value that you can get. And then you just flip-flop them for your inverse function. The graphs for these, I made 2 tables. I only plugged in 2 points, but just recognize that because the domain is going to infinity for this first graph, that's in black. But your first point was 0, 4.5. And then for the other graph, it goes to infinity on the y-axis, but it stops at 4.5, 0. So they look kind of gross, but then you get the idea, hopefully. And then the last step is to find the derivative of each of those and plug in the x's that they give you, the coordinate. Because there's only the slope that we're looking for, you only need to plug in the x, but you had to use quotient rule for the original function, or you could turn it into 9 times 2 plus x squared to the -1 if you want, but you have to use chain then. So either way, you get -2 for your slope at that point. And then same thing with this one. You can either use chain and then quotient, or you can actually turn this into 9 over x minus 2x over x, which is the same thing as -2, and raise that all to the 1/2. If that's easier for you, feel free to use that instead, which is what I did to get this part, the derivative of the inside. So it'd be 1/2 9 over x minus 2 to the -1/2 times the derivative of the inside, but the derivative of the inside, you have to do 9x to the -1. So add power, divide by that. Hence why I got the 1/2, and you end up with -1/2 as your slope. So they are reciprocals of each other. Hopefully you're good there. Okay, so the last little bit here, guys, is just on the back side. It's a little different for us, so I'm going to go through them with you. Okay, so we're going to do the top first, and then I'll have you try the bottom as per usual. Okay, so use the given functions to find the given values. So what that means is what they want you to do first, just be careful, this is not saying that these are inverses of each other, because they're actually not. They want you to find, for these 2 separate functions, they want you to find the same thing as inverse f of inverse g of 8. Okay, so that means you need to find the inverse for both of them. So what I would do is actually calculate the inverse for these. So again, switch your x and y. So x equals 2y plus 5. So y is going to equal x minus 5 over 2. So inverse of f of x is x minus 5 over 2. And then do the same thing for g of x. So just so you know, you end up with 3x minus 12 is the inverse, which is nice. It did not look like a 2. Okay, so if I were to do f inverse of g inverse of 8, all they want you to do is plug in 8 for the inverse of g, and then plug it into the inverse of f. So what that looks like is 3 times 8, because I'm plugging in 8 for my g inverse. I don't know why that's making that noise. And then I plug this answer in for the inverse for f. So it'd be f inverse of, you get 24 minus 12, which is 12. So you plug that in for your inverse for x, for f. So it becomes 12 minus 5 over 2. which ends up giving you 7 over 2. And you can just leave it as a fraction. The next one, same thing. This is the nice part about us already having done the inverses, is now I can just do G inverse of F inverse of 2. And then I get G inverse of plug in 2 for the inverse for F. So you get 2 minus 5 over 2, which is negative 3/2. Plug that in for the inverse for G, and you get negative 33 over 2 for that one. Okay, and then the last one, what's weird is they want you to find the inverse of F. So basically you're plugging it in twice. This is the same thing as F inverse of negative 2. So plug in negative 2 for the inverse of F. So negative 2 minus 5 over 2. And then you have to plug it back into the F inverse again. So negative 7 over 2. And then you plug that in back again. So it's negative 7 over 2 minus 5 over 2. So I would just do like 1/2 times negative 7 over 2 minus 5. And you end up with negative 17 over 4, it looks like. All right. Do the same thing for the bottom question, please. You should have your PDF open so you can see it, but try all 3 questions and I'll have the answers up for you in a sec. All right, guys, so this one you don't have to plug in values for, you're just plugging in each of the functions for each other. So for this, just a reminder, you're plugging in G for f of x. So for the first one, you're taking this and plugging it in for that x. So it becomes x plus 3 plus 4 over 3. So it simplifies to this. The next one, you have to do the opposite, where you're plugging this in for that x. So you end up with x plus 4 over 3 plus 3. So you should get a common denominator. And you get x plus 13 over 3. And the final one is a little bit harder because the inverse is on the outside. So you have to do f of g of x, the original functions. So you're literally doing 3 times x minus 3 minus 4, and then you're finding the inverse of that. So this ends up being 3x minus 13, and then you'd have to find the inverse of that. So it would be like x equals 3y minus 13. If you got this question, congrats. And that is the same thing as this. All right, folks, that's it for the 5-3 notes. We have 3 chapters or 3 sections in this little unit. So you're going to learn about 5-4 and then a little bit of 5-5, and then we are going to do a cumulative little assessment for that. So you don't have a quiz for a little while. So enjoy. Have a good one.